Hello, guys. Welcome to another episode of CUDA Education. I am going to start to tackle the topic of the shader binding table. Okay, so I'm going to quote the very first paragraph on this topic from the Vulkan spec, and I quote: a shader binding table is a resource which establishes a relationship between the ray tracing pipeline and the acceleration structures that were built for the ray tracing pipeline. It indicates the shaders that operate on each geometry in an acceleration structure. In addition, it contains the resources accessed by each shader, including indices of textures, buffer device addresses, and constants. The application allocates and manages shader binding tables as VK buffer objects. End quote. After this particular introductory paragraph, everything else gets scarier than Halloween. So we're not gonna I'm not gonna delve any further. But I do want to actually pick apart what is actually said in this very first paragraph. Okay. So it's a resource which establishes a relationship between the ray tracing pipeline and the acceleration structures. Now, as of this point in the series, I have gone over acceleration structures, right? And my personal understanding of acceleration structures, it's like a pre-processed blueprint of what the ray tracing or the ray trace scene is, right? So you kind of generally tell the Vulkan and the application what is where and things of that nature. You have a bottom level acceleration structure, which is like the actual geometry in the scene, and then you have a top level acceleration structure which references the bottom level acceleration structure, um, and that more deals with instances and the number of instances in the scene, etc., 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 etc. Okay, so we kind of have touched on acceleration structures. Okay, in a very real way, sort of in this code that we're dealing with, and of course the code is let me make sure that I didn't I put it back to the way it was before. Um, but it I will run it again, but it's basically, as in the previous videos, it is dealing with generating a triangle, right? So I kind of want to pick apart this whole definition. We haven't really gone through the ray tracing pipeline as yet. I mean, we did initially in one of the videos, like on a very high level, just a diagram of the ray tracing pipeline. But I kind of want to start dealing with what exactly is the shader binding table thing, right? So okay, so it's a relationship between the ray tracing pipeline and the acceleration structure. So we went through the ray tracing pipeline, and then we kind of went through the acceleration structure. um Indicates the shaders that operate on each geometry in an acceleration structure. So I guess the geometry for our situation here is a triangle, right? um Let me just what was it? Right, it was this guy. Let me just clean up the code to back to what it was before, so that I could actually just run the script, and I could run the script and just show the triangle, right? So in our very simple ray traced example, the geometry that I'm assuming that we're dealing with is three vertices that makes a triangle. Okay, that's how I look at things, right? So when we run the code, we should see a triangle, right? And this is a ray trace triangle, so it's not just a regular triangle, it's a ray trace triangle. Okay, so we have three vertices, and I guess the rays are coming in and hitting what we have outlined, and that's what we see here, right? The code is significantly different from the regular triangle example, right? So we have ray tracing basic and we have triangle, and of course triangle Vulkan 1.3, but triangle, okay, which is like non-ray traced. All right. So right, we have this. Right. So we have the shader bindings table stuff. We have the raygen, miss, and hit. Okay. Um, right. So it indicates the shaders that operate on each geometry in an acceleration structure. Okay. So we're dealing with a triangle, so the geometry is a triangle. In addition, it contains the resources accessed by each shader, including the indices of textures, buffer device addresses, and constants. The application allocates and manages shader binding tables as VK buffer objects. All right, this part, we're not really gonna dive into quite yet. I know in the code there's, a lot of buffer device address references. Um, the VK buffer object, as far as I'm concerned, is just a buffer object for Vulkan. I mean, I don't want to dive into that too much. So, yeah, I, this is just the introductory video about this topic. I basically wanted to, as sort of my contribution to the discussion, I wanted, I wanted to deal with this guy right here. Instance, shader binding table, record offset. Um, Table record off. Okay. Okay, so hit shaders. Okay. Okay, so remember now, the spec talks about the shader binding table being a resource between the ray tracing pipeline, and I mean being a resource which establishes the relationship between the ray tracing pipeline and the acceleration structures that were built for the ray tracing pipeline. So um, this so we're at this thing is at line 408. So uh, okay. Um, okay, so when it talks about the hit shader, right, which is I guess this guy, the hit, it talks about the hit shader being so we're at the hit shader. I'm looking at the hit shader discussion, and I specifically want to instant shader binding table record offset. I'm kind of focusing here because I've kind of tinkered with the code, and there's some nuance to this. So I'm gonna I'm gonna start with this particular discussion, and then work our way elsewhere to get a better understanding of these shader binding tables. Okay. Um, so instant shader binding table record offset, right? This guy right here. In the spec, under the hit shaders subheading, I'm going to quote a reference to this particular instance shader binding table record offset. It says the base for the computation of intersection, any hit, and closest hit shader locations is the instance shader binding table record offset value stored with each instance of a top level acceleration structure. This value determines the beginning of the shader binding table records for a given instance. And then, of course, it gets scarier, but I'm just going to pause here. Okay. So it's a value stored with each instance of a top level acceleration structure. All right, so we're dealing with the top level acceleration structure. And remember now, the top level acceleration structure deals with instances of stuff. So bottom level is the actual geometry, and top level is dealing with the instance, or maybe the number of instances and all of that stuff, right? So this instance shader binding table record offset is dealing with um it's dealing with a top level instance related stuff. This value determines the beginning of the shader binding table records for a given instance. Okay, so obviously when we run our code uh, correctly with everything as the script outlines, we get a regular table, right? But then, here at CUDA Education, we like, we're in the business of learning, and we're in the business of learning Vulkan, and we're in the business of learning what exactly the shader binding tables is and what it does and all of that stuff. So what we're gonna do is we're gonna start to mess with this offset, because I kind of want to see what happens when the instance is not when the instance is not properly aligned with this shader binding table concept. Okay, so what happens when I change it? Instead of it being 0, which it correctly should be, I change it to 10. Now before I actually run the code, I want you guys to actually make a guess, right? What do you think is gonna happen? Okay, um make your guess before we actually run the code. So I'm gonna rebuild ray tracing basic in the meantime. But think about, this is associated with the top level acceleration structure, instance related stuff. This value determines the beginning of the shader binding table records for a given instance. So what happens when the records in the shader binding table is off? What should happen? All right, so now we're going to run our the script with the shader binding instance shader binding table record offset being off. Okay, like it's not where it's supposed to be. Okay, so survey says this guy. Um, so I don't know if you could see, but basically we do have an outline of a triangle, but the colors aren't there, and like it's not colored, it's not illuminated, it's not highlighted. Okay, um, this is what happens when you when the offset is not correct, right? When it's not in sync. Now, at this point in time, I'm not well versed into to being able to tell you why this why what we're looking at is happening, right? My sort of very basic guess is that the shader binding table isn't correct, right? Um, Maybe nothing has been hit, and as a result, um, the rays the rays aren't seeing any hits, so nothing is being highlighted, nothing is being illuminated. Um, yeah, that's just my guess, right? Um, but I don't know. Uh, I don't necessarily recommend you doing this on your system. If you know, install these scripts and install this example, I don't recommend you doing it, because if you make this value really high, like if you make it like 100 or so, because I've been playing around with it, right? I made the value really high, and then what happened is that like literally my whole display flickered and like went out of, you know, went blank and then came back and all that stuff. So, you know, full disclaimer, not liable for any adverse effects on your system. You know, I don't know exactly what's going on. You know, I do these things so that you don't have to do these things. But yeah, I just wanted to do a full disclosure that, you know, don't necessarily start playing around with this, because I don't know if it's messing around with your GPU, if it's messing around with your the basic display of your system. I don't know. Um, so even with an offset of one, I haven't actually done an offset of one. I've done 10 and so, but we get the same result, right? So if I do 100, if like I change this to 100, I'm gonna get like an abort. You know, it's gonna go really bad. It's gonna have an outright error, runtime error, and like, do you want to abort and retry and all that stuff? I don't want to do it here while I'm recording, because I might lose this recording and I don't feel like redoing this whole discussion again. So um, I'm just gonna set everything back to 0 and rerun it as the way it should be, and we should get back our triangle as we know it, right? So the Vulkan spec is readily available to everyone online. It's a free resource. You know, I can't. They don't really like when people, you know, show the Vulkan spec verbatim. So I'm going to respect their wishes and not do that. I can quote, you know, certain specific things for education purposes, but I'm not going to, yeah, you know, I'm not going to violate, you know, their rules and their thing. So that's the only thing I have for this shader binding table discussion. I still need to put some energy into it. Um, you know, and really figure out what's going on. As you can see, we had our table again. Um, but right, so we have our hit, we have our ray gen, which is, you know, generating rays into the scene. Then we have our miss and we have our hit, right? So, you know, I was hoping that at least the I was hoping that at least the you know, if I just did a little offset that like, you know, part of the triangle would be illuminated or something like that, but I guess it doesn't work that way. Um, but yeah, I will put more energy into shader binding tables. I think it's a very important concept. I wanna really understand the shader binding table, and then of course get into the full ray tracing pipeline itself. So I might be doing this a little bit the wrong way, but I don't care. We already did acceleration structures, and um, you know, we have to do the ray tracing pipeline, but the shader binding table stuff is important. It's like a record keeper, and I want to tinker with like, you know, what happens when the shader binding table, the hit shader binding table is empty. I'm assuming kind of like what we saw a while ago. What happens when um, the miss table is empty? What happens when the miss table is full? You know, what happens when the regen table is turned off or is empty, and when it's full, you know, what exactly happens? What is our guess? And really see. But yeah, I need to spend more time with this stuff to figure out what's going on here. But yeah, guys, if you want to learn Vulkan, you got to check out tutorial number 1, which is installing the Vulkan SDK. It's a video walking you through the whole process of installing the Vulkan SDK. And then tutorial number 13, which is installing all of these examples, okay? So it's a whole bunch of examples that you could have on your system, and you could learn Vulkan in the process. You need a Windows-based machine, with a Vulkan capable GPU. If you want to run the ray tracing examples, you need to make sure your GPU has ray tracing capabilities. In the case of NVIDIA, it has to be RTX GPU or greater. Don't know anything about AMD GPUs, don't know anything about Intel GPUs. But if you if you want to start the journey, for those of you creatives, artistically inclined, if you want to be relevant in the digital era, you need to know how to put pixels on a screen, and it involves all of this stuff that you see here. So that is my contribution for today in the Vulkan discussion. Thank you for your time. Tell your friends, get a bunch of your friends together and work on this as a group. And you guys could tinker with code to your heart's content and learn Vulkan in the process. All right, guys, have a great day. Bye.